Here the question says that let n be the number of functions f from the set of a to a, where a is simply the set 1, 2, 3, 4, 5 all the way up till 2018, satisfying the condition that f of k is less than f of I plus k minus a for all integers I comma k such that 1 is less than equal to I less than k less than or equal to 2018. Then the correct options are, and then we are given basically four options. So quite an amazing problem from the level of advanced, and it is a more than one option type correct question. So now let us have a look at the correct solution. So the very first thing that we can do is we can put k equals to I plus 1, and the reason is that k is simply greater than I. So obviously we can put it as I plus 1 because obviously that is greater than I. So putting that value of k here in this inequality, we simply obtain f of I plus 1 is less than fi plus 1. So that would imply that since these are all integral values, so f of I must be less than or equal to f of I. The reason is very simple, that let's say if somebody tells us that x is less than 5, then obviously that implies that x has to be less than or equal to 4 as long as x is an integer. So that is exactly the kind of logic that we have applied from in this statement. So now in this particular relation, if we put I equals to 1, 2, 3, 4, 5 all the way up to 2017 successively, then we'll be obtaining something like that f of 2000 is 2018 is less than equal to 2017 is less than or equal to f of 2016 all the way less than or equal to f of 1. So from here it is clear to us that f is a non-increasing function. And now in the range of f, let us assume that 1, 2, 3, 4, 5 all the way up till 2018 are being used x1, x2, x3 all the way up till x 2018 times. So basically we have assumed that in the codomain we have the numbers 1, 2, 3 all the way up till 2018. So we have assumed that exactly x1 number of mappings have been done to the number 1. Then similarly, we have assumed that from the domain, exactly x2 number of elements have been mapped to the number 2. Similarly, x3 number of numbers or x3 number of elements have been mapped to the number 3 from the domain. And similarly, x 2018 number of mappings have been mapped to or number of elements have been mapped to 2018 in the second set. So this is exactly the logic that we are using, and thus we are saying that these numbers are being used these many times, or they occur in the range of f these many times. Now obviously x1 plus x2 plus x3 all the way up till x 2018 would be 2018. The reason is that the domain has got 2018 elements, so obviously the total number of mappings is going to be 2018, since all 2018 elements are going to be mapped to some or the other element. So the total number of mappings is obviously going to be 2018. That's why this total number of mappings is equals to 2018. Obviously, xk is going to be greater than or equal to 0, because it is quite possible that some number might not occur in the range. Nothing might be mapped to it. It might not even occur in the range. So equal to 0 is also possible. Clearly, the number of integral solutions of this equation are these many: n plus r minus 1, cr minus 1, which gives us 4035 C 2017. Now, once these xi's are assigned their values, there is only one way to map the elements of domain to the codomain due to the non-increasing nature. So due to this fact that it is a non-increasing function, there is going to be only one and only one unique way to assign them. So let's say we come to know that one is being used, let's say 3 times, two is not being used any time, this might be used, let's say 2 times, this might be used, let's say 1 time, like that. So it is quite obvious that due to the non-increasing nature, 2018 will have to be mapped to 1, 2017 will also have to be mapped to 1, because there are 3 elements, so the last 3 elements must be mapped to 1. Then it is not mapped only, so we leave it alone. Then 2015 will be mapped to 3, 2014 will be mapped to 3, because there are 2 times it should occur. Then the next element, so basically it would be mapped to 4. So in this manner, there is only going to be exactly one way to map once the x's are decided, and hence due to the non-increasing nature, this is going to be our final answer. N equals whatever we obtained here. Now, once we have obtained the value of n, it is very simple. So let us first consider this sum. Let us call this sum as q, which is equal to summation of 2017 C CR square summation from R equal to 0 to 2017. So we know that summation of NCR squares is simply equal to 2NCN. Here in our case, n happens to be 2017. So using that formula, we get exactly the value of n now, or the value of q rather. Now, since we already have n, we find n by q. So their ratio obviously comes out to be this much. It is very simple to find this ratio. Just we have to expand it, nothing else. So just expanding like 4035 factorial over 2017 factorial, blah, blah, blah. Canceling out the things, we'll simply get this value, which is clearly greater than 1 but less than 2. So we can see that n by q lies between 1 and 2. So n obviously lies between q and 2q, and hence the option number B would be correct, because this is q, this is 2q. So n is clearly lying between 2 to q2, right? 2 to 2, basically lying between q to 2q. Now, talking about the last two options. So we have considered this sum. Now, all that we are doing is we are using this property NCR plus NCR minus 1 equal to n plus 1 CR. And this is simply equals to 1, right? This, its value is 1, but its value is also 1. So 2016 C 2016 we have written as 2017 C 2017, and remaining terms have remained unchanged. Now NCR plus NCR minus 1, if we do here, it will become n plus 1 CR, and then the remaining terms will remain unchanged. So those have been written as it is. Now again NCR plus NCR minus 1 we can use here. So it will again become n plus 1 CR. Recursively applying this all the way up till the end, it will become 4035 C 2017, which is nothing but n itself. Similarly, the last summation, also we are using the exact same technique, where this, since we know that since this is equals to 1, so we are writing it as basically 2018 C 2018, and then again applying NCR plus NCR minus 1 formula, recursively we'll get this value. But obviously NCR is also equals to NCN minus R. Using that property here, we get its value equals to this, which happens to be 4035 C 2017, which is also equals to n. And hence the final correct options are B, C, and D, which are our correct answers. Now, there is also another method, aliter, or an alternative method. So the very first thing we can do is we can write the given inequality in this way. We can bring k to the other side. Now we can define gx as f of x minus x. So clearly the inequality becomes g of k is less than gi for all I, such that whatever condition was given in the question. So obviously we can see that g of x is a strictly decreasing function. Now obviously domain can only vary from 1 to 2018. Similarly, the range of the function is also going to be between 1 and 2018 only, because the sets are exactly the same, both domain as well as the codomain. So it is very clear to us that if x is lying between these two numbers, and if fx is lying between these two numbers, so what we can first do is we can multiply this inequality by negative all the sides. So we'll basically get that this lies between minus 2018 to minus 1. Now adding both these inequalities, we'll get fx minus x lying between 1 minus 2018 to 2018 minus 1. So since this is g of x, so g of x lies between minus 2017 to 2017. So basically g is a strictly decreasing function, which can take values from this set minus 2000. Basically we have written the set here also. So what we are saying is that since it lies between minus 2017 to 2017, all the possible values that g of x can take or assume or attain is going to be this set of values. So from this set, any value it can attain, right? Now, since it is a decreasing function, g1, g2, g3, all the way up to g 2018, they must take distinct values, obviously, because a strictly decreasing function is also monotonic in nature. So it cannot attain same value at two different points. So obviously they are all going to be distinct values, right? Now, they are going to take the distinct values from the set A, which is minus 2017, minus 2016, all the way up till 2016, 2017. So, obviously, this set contains 4035 elements. So, from these 4035 elements, we can select any 2018 values which will be in the range of G, because obviously there are only 2018 elements that are in the domain. So, and all of them will be mapped to distinct values. So obviously we'll need 2018 values only for the 2018 elements in domain to be mapped to, right? We can, so what we do is we select out of these 4035 any 2018 elements. So that's exactly what we are doing. But once we have selected them, there is only one way to map or assign them to G, because G is a decreasing function, right? So obviously the highest value will be assigned to G1, then the lowest value will be assigned to G to 2018. So basically once selected that what numbers are going to be in the range of G, there's only one way to assign them. And once G is defined, F will automatically be defined due to Fx being equals to Gx plus X. So once we have defined G of X, every Fx is automatically mapped, right? Because for example, what is f of 4? It is clearly G of 4 plus 4, and whatever value this is, that has already been decided above. So this will automatically come out to be a fixed number. So we cannot do anything now. Automatically the function f has been defined so that the number of functions g is equal to the number of possible functions f, and hence n comes out to be the same number that we had obtained earlier. Obviously this is also the same as writing 4035 c 2017, both are same. So I hope you all were able to follow through. Thank you.